modelling growth and decay. So this is geometric one in particular, so please be aware of that. So with geometric, we're either multiplying, and that means like this one's multiplying by 3, we're going up, or there's the decay, which we're multiplying, but we're multiplying by a number less than 1, so the half, quarter, etc., and therefore it's going down. We still need to write a recurrence relation. We have our R's, whether the times by 3, times by 4, whatever it is, or if it's really strict minusing, we'll do it later, and I'll show you how to work all this out. So example 1 says, the following recurrence relation can be used to model compound interest investment of $2,000. There's our V of 0. Paying interest at the rate of 7.5% per annum. So how did they get this one over here, 1.075? Well, the original amount of $2,000 is worth 100%. Then they're getting charged 7.5% per annum interest. So this altogether is 107.5%. And as a decimal, that is written as 1.075, because remember we divide by 100. So that's how we get that. So we can do this two ways. This one here I'm going to show you how to do it the long way, just in case they ask you in the exam. So use the recurrence relation to find the value of the investment after 1, 2, and 3 years. So after 1 year, we have 1.075 times V of 0, which is $2,000. And when we do that, we're going to get 2150. V of 2, we're going to go 1.075 times V of 1, which is 2150. And of course, when I work that one out, we're going to get 2311.25, and then V of 3, and go 1.075 times V of 2, which is 2311.25, and that gives us 2484.59. Part B, determine when the value of the investment will first exceed $2,500. So when is it? Just keep going. You've got to calculate, keep going, you'll find that it's after 4 years. Part C, write down the recurrence relation. If $1,500 was invested at a compound interest rate of that much per annum. Okay, so we've got our V of 0, there it is, $1,500. We've got to work out our capital R, because remember it says V of n equals capital R, V of n plus 1 times V of n. Okay, so our capital R, we've got the original 100%, we're going to add 6% because it's compounded, which means it's 106%. As a decimal, we're going to divide it by 100, so we get 1.06. So our V of n plus 1 will equal 1.06 to the power of n times V times V of n, because it says a recurrence relation. So no, it's just 1.06 times V of n. Example 2. Brian borrows $5,000. There's our V of 0. Pay interest at that rate. V and be the loan after n compounding periods. Write down the recurrence relation, and this one's yearly. So here, we've got 100%, that's his original amount, and he gets charged interest, which is 4.5%. So he's got 104.5%. We're not adding together, which means as a decimal, divide this by 100, 1.045. There's our decimal. So V of n plus 1 equals 1.045 times V of n, where V of 0 is $5,000. Part B is the same thing, but this time quarterly payments. Well, we've still got the 100%, that's not a problem, plus the 4.5%, this is per year. How many quarters are in the year? There's 4 quarters in the year, so I'm going to divide it by 4. So this makes it 100%, plus when I divide this by 4, I get 1.125%. Add them together, that is 101.125%, divided by 100, going to 1.01125. There's my decimal. So V of n plus 1 will equal 1.01125 times V of n, where V of 0 is still $5,000. That has not changed. Part C wants it monthly. Okay, got to work all this out again. 100%, 4.5% for the year. How many months are there in a year? 12. So I've got to divide this by 12, which means it's 100% plus the 0.375. 4.5 divided by 12 is 0.375, which means it's 100.375%, and as a decimal, 1.00375. Now I can write my rule. That is 1.00375 to the power of Vn, where V of 0 is $5,000. That has not changed. Okay. Reducing balance. Remember, reducing balance means it is subtracting, not adding to get it. Okay, so we're depreciating. Example 3. The following recurrence relation can be used to model the value of the office furniture with the purchase price. There's our V of 0, $6,900, depreciating at 7% per annum. So how did they get the 0.93? Well, originally we've got 100%, but it's depreciating, so going down by 7%. Okay, when it goes down by 7%, that means I've got 93% left over. As a decimal, 0.93. That's how we get that 0.93. Okay, use the recurrence relation to find the value of the office furniture. Correct to the nearest cent after 1, 2, and 3 years. This time use your calculator. So 6,900, that's our original, press enter. And go times 0.93 and press enter as many times as you want it. After the first one, V of 1, we get 6417. Press enter again, and you get 5967.81. Press enter again, and you get 5550.06. Determine when the value of the investment will be less than 5,000. Well, we're close to 5,000, so just press enter again. You need to press it 2 more times, so that makes it 5 years when it goes less than $5,000. Then part C says, write down a recurrence relation if the office furniture was initially valued at 7.5, there's our V of 0, and it depreciates, reducing balance at 8.4. So okay, so let's work out our percentage. So we've got 100%, but we're depreciating by 8.4%, so that means we've got 91.6% divided by 100 to get the decimal one, 0.916. Now we can write V of 0, 7,500, V of n plus 1 equals 0.916 times V of n.